Hello, hello. Here is the video going over our Unit 1A, 1B test review. This video will cover transformations, piecewise functions, as well as characteristics of graphs. So the first thing we're going to be doing is graphing functions and their transformations. So for letter A, I have f of x equals negative 1/2 absolute value of x minus 2 minus 2. So the first thing you want to do is we want to actually list our transformations because that's going to help us create the graph. So the negative in the very front represents a reflection. Oh, wrong color. A reflection over the x-axis. There is also a vertical shrink of 1/2, and that minus 2 on the inside means we are moving to the right 2, and minus 2 on the outside means I am moving down 2. Now, before I actually start graphing with the transformations, I do want to graph the parent function. So absolute value normally starts at 0, 0, and then I go to 1, 1, negative 1, 1, and then I have this absolute value graph that goes up to the right and to the left in a nice V shape. So what I want to do is I want to take this graph and actually work through the transformations. So I will be reflecting over the x-axis, which means instead of opening up, it will be opening down. I will shrink vertically by 1/2, also move to the right and down 2. So what I'm going to do is I'm going to take this first point, 0, 0, and start moving it around. So I'm moving to the right 2 and down 2. So that puts me right here. I do know that my graph needs to go down because of the reflection, so eventually it's going to look like that. I also know that I have a vertical shrink of 1/2. So normally our absolute value opening down would have those points spaced out 1 unit apart vertically. But since I have a vertical shrink of 1/2, it's actually going to be spaced out vertically by 1/2. So now my points are right in between those two grid markers, and then I can go ahead and connect those, and that is going to create your vertical shrink of 1/2, which makes your graph wider. Whoops, didn't mean to do that. For letter B, g of x equals 3x minus 2 squared minus 1. So that 3 in the front is a vertical stretch. I am moving to the right 2 because of that minus 2, as well as down 1 because of the minus 1 on the outside. So I'm going to start by graphing my parent function first. So normally x squared looks like this. It does have the same starting points as your absolute value function, but of course your x squared function is a parabola and not a V-shaped graph. For this one, we are going to start by taking my point at the origin and moving it around. So I'm moving to the right 2 and down 1. So that's where it puts my vertex. And normally my points are 1 unit apart vertically, but because I have a vertical stretch of 3, I am now going to space them apart by 3 units. And what that does is it makes your graph more narrow. So you can see when I compare my pink parabola to the purple one, my purple one is skinnier. All right, letter C. So this is a square root function. I'm going to go ahead and plot my parent function. So there is your normal square root function. My transformations, the negative means I have a reflection over the x-axis. I am also adding 2 on the inside, so that means I'm moving to the left 2. Subtracting 3 on the outside means I am moving down 3. So again, I'm going to go ahead and take this point at 0, 0 and move it around. So I'm going to go to the left 2 and down 3. Since I do have a reflection over the x-axis, instead of my square root function going in this direction, it actually needs to go in the opposite direction. So it's going to be doing something like this. But I do still need to plot some points for accuracy. So this one does not have a stretch or a shrink at all. So normally I can see right here my points are 1 unit apart. So I'm going to do the same thing, except I'm going to put it below because it is going to have a reflection over the x-axis, which means instead of going up, it is now going down to the right. All right, number 2, we are working backwards. So now I am giving you the graph and we want to write the equation. So if I look at the first graph for number 2, I can see that it is an absolute value function because of the shape. It is a V shape, so that's y equals absolute value of x. Normally my parent function, which I'm going to show you in pink, is right here. But of course, because of transformations, I now have the graph that is in red. So I just need to figure out what those transformations are. I can see that my graph is wider, which means there is a shrink. So vertical shrink. And I can see that my points right here are in the middle of my grids. So it's a vertical shrink of 1/2. I can also see this point was shifted 2 units to the right and 1 unit down. So putting all of that together, I'm going to put my 1/2 in the front. That is my vertical shrink. Moving to the right 2 means I'm subtracting 2 inside my absolute value. And moving down 1 means I am subtracting 1 on the outside. My second graph is a quadratic. Here is your original parent function for your quadratic. So my parent function is y equals x squared, and let's figure out our transformations. I can see that my graph is opening down, which means we did have a reflection over the x-axis, which means I am going to have a negative in front of my function when I do write my equation. I can also see that my parabola is a little bit wider because if I look at my points right here, they're once again in the middle of my grid. So we're going to go ahead and assume that that's at 1/2. So let's see, this is a vertical shrink of 1/2. The graph did not move to the left or to the right at all. Here's my vertex. The vertex just moved up 2 units. So my equation, f of x equals, I have my vertical shrink of 1/2. I did not move left or right at all, so that's just x squared. And I moved up 2, so plus 2. And I did forget to put something in my equation. Hopefully you noticed because you're paying extra close attention. I forgot my negative in the front. There we go. So that negative in the front is going to give us that reflection over the x-axis. All right, number 3, graphing the piecewise functions. So in order to graph the piecewise functions, you do need to pay attention to your restrictions on your domain. So for my first function, which I'm going to go ahead and graph in blue, that is when x is less than -1. For my second function, which I'm going to graph in pink, that is when x is in between -1 and 2, inclusive on both of those because of the or equal to. And for my last function, that is when x is greater than 2. So I do have these boundaries between my domains at -1 and 2. So what I like to do is I like to actually draw these boundaries because that's going to help me figure out where each piece of my graph is going to go. So I like to make them vertical dotted lines. Okay, so for my first one, it is a linear function, so 2x minus 3. So in order to graph that, I'm going to start at my y-intercept, which is at -3, and I'm going to go up 2 over 1, up 2 over 1, and so forth. I'm going to go in the opposite direction as well. Now, if you'll notice, right now, the way that I'm graphing all over the grid. But really, this portion of the graph is for when x is less than -1. So really, my line should only be on this side of my wall. But sometimes it is helpful to graph everywhere so you can get an idea of where your graph is supposed to go, and then you can just go ahead and erase the other points. So another thing that I notice is when my domain says x is less than -1, which means this point right here that is on my wall should actually be an open circle, because that inequality does not have the or equal to. So I'm going to make that an open circle. I'm also going to erase these other points, since technically they are not supposed to be there. And then you get this graph over here. Just your itty bitty graph in that little section. All right, for my second function, absolute value of x minus 5 means I went down 5 units from my normal absolute value function. So I'm going to have this point right here. Normal absolute value function is going to go up 1 over 1 in both directions. And as I'm plotting my points, I'm just plotting them for now, and then I can make adjustments later on if I need open circles or closed circles. So looking at my domain, both of these have or equal to's. So that means when they do hit the two walls, they should be closed circles, which is exactly what I plotted. So I don't have to make any changes there. So I can go ahead and sketch my V, and that gives us the middle piece of our graph. Okay, for my purple piece, x squared, that is for all of the values that are greater than 2. I do need to see where it's going to hit my boundary, so I can go ahead and plot that point. So I am going to take 2 and plug it in just to see where it's going to hit that boundary. 2 squared is 4. So on my boundary, I'm going to have an open circle at 4. Now, normally, x squared looks something like this, right? Where you have your quadratic doing something like this. But since my domain is for everything that's greater than 2, all you really have is a skinny little piece on the side for this particular piecewise function. So it does look a little weird, but that's just how the graph ends up looking for that piece. So then I got my purple piece, tiny little sliver on that side. Okay, so to actually evaluate my functions, I need to decide where this number is going to fall. So f of -1, this right here is your x. -1 is your x, and I need to see where which function to plug into. I can also look at my graph and see where my y coordinate is when x is -1, and you can see you have two options here at -4 or -5, but we always want to pick the one that's a closed circle, so that's at -4. So f of -1 is -4. You can also solve it algebraically. So since I have this or equal to, that means I would plug into the pink function. So when I do that, absolute value of -1 minus 5 is going to give you that -4. For f of 2, let's see, I have two options. I can plug into this one or this one, but again, I do need to pay attention to my inequality. Your middle function has that or equal to, so I'm going to take 2 and plug it into the middle function. So that is going to give me absolute value of 2 minus 5, which is -3. And f of 8, 8 is bigger than 2, so I'm going to plug into that last function of x squared. So 8 squared is 64, so f of 8 is 64. All right, number 4. So for this one, we are going to be writing equations for absolute value, or not just for absolute value functions, for piecewise functions.